do some optimization problems. Example 1 says a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with maximum volume? So we're looking for maximum volume. The first thing you want to do is look for what's given. So we know we're going to have a box with a square base. Okay, we don't know what the sides are, so we'll just call them X. Okay, and we don't know what the height is, so they just called that H. So you can draw a picture. Now it's an open box, so it doesn't have a top. So this is what our picture would look like. We also know the surface area is 108 square inches, so that's another hint that they gave us. Okay. Now the first thing you want to do is check and see what your primary equation is. To get your primary equation, you want to figure out what are you maximizing or minimizing. In this case, we are maximizing volume. That would be our primary equation. So let's talk about the equation for volume of this box. Volume of a box is length times width times height. Now because this box has a square base, that would be X times H. And that would be V equals X squared times H. That would be the equation for volume of this box. That's the first thing you want to do. Okay, let's put a little 1 there. Now the second thing we want to do is figure out our secondary equation. Now the secondary equation comes from the information they gave you. Okay, so we're going to use the fact that surface area is 108 square inches to come up with a secondary equation. Now the surface area of this box would be the area of each side. Remember, it's an open box. So the bottom would be X times X. Okay, that one's a square. That gives you X squared. Each side will be X times H, and there are 4 sides. So surface area of this would be X squared plus 4 times X times H, and that is equal to 108. Now, in order to solve this problem, we need to get our primary equation in terms of one variable. We don't want an X and an H, okay? Let's do just an H, or excuse me, just an X. So let's get rid of the H. To do that, what we're going to do is we're going to take this problem and solve it for H. Okay, we want to get H by itself. So the first thing I'm going to do is move this over, and I'm going to have 108 minus X squared equals 4XH. Now, I want to get H by itself, because I'm going to use it to substitute in just a minute. That means I have to divide by 4x. So I'm going to divide this by 4x. Then we get H equals 108 minus X squared over 4x. Now what we want to do is take this is our secondary equation. Now that we have it solved for H, we're going to take this and we are going to plug it in right here. Okay, so we're going to take the H out and we're going to put in 108 minus X squared over 4x. We're going to put that right in here. So it would look like this. See, now we only have one variable. We just have X's. Okay, so let's go over here and let's do a little side note. Let me get a different color so you can follow. I skipped a few steps. Let's fill them in. We're going to distribute the X squared here. Okay, so we're going to put it here and here. And I'm going to have 108 X squared minus X to the 4th, when I do X squared times X squared, over 4X. Now I can put the 4X under both, so I have 108 X squared over 4X minus X to the 4th over 4X. And that will reduce to, here we get 27x minus, this would be 1/4 x cubed when we reduce our x's. And that's what they have right here. Okay, they wrote it a tiny bit differently. So now what we want to do, we've done all this to get rid of the h. So we have everything in terms of x now, and we're ready to take the derivative. Because in order to optimize this problem for maximization and minimization problems, you take the first derivative. Okay, So we have V equals 27x minus 1/4 x cubed. Take the derivative of that, and you are going to get derivative of V with respect to x is going to be dv dx equals derivative of 27x is 27 minus 3 times 1/4 is 3/4. And you take 1 away from your exponent and you get x squared. So we have 27 minus 3/4 x squared. Now to finish solving this, to get our critical values, we're going to set that equal to 0, which they did here. Okay, so the first thing you want to do from this step, let me get a different color again. So we're going to go from this step, we're going to move our 27 over, and then we're going to have negative 3/4 x squared equals negative 27. If you multiply both sides by negative 4, you get 3x squared equals 108. When you divide by 3, you get x squared equals 36. Now remember, when you take the square root of both sides, you have to put a plus or minus. And that's how they got plus or minus 6. Now you guys, we know with a problem like this, it can't be negative, okay? It's got to be a positive 6 because we can't have a negative distance here for our x, right? So we're going to have actually a positive 6 for our critical value. Now, if you want to test it and make sure that this is going to give us what we need, different color here. If I plug 0 into this first derivative, I get a positive. It is going up. I get a positive 27. And if I plug, let's say, 7 into this derivative, we're going to get a negative. It's going to be going down. So we did find a maximization. Okay, so we know that x is equal to 6. When x is equal to 6, we have a maximum volume. Now, if we want to solve this for the height, let me come over here a little bit. If we want to solve for the height, we know x is equal to 6, okay? So for our maximum volume here, we would plug that back in. We could plug it back into this equation and solve for h. So we would have h equals, let's come back over here, sorry, it's kind of messy, 108, oops, fix that, 108 minus 6 squared over 4 times 6. And if you solve that, h is going to be equal to 3. So that tells me my dimensions would be 6 times 6 times 3 in order to get the maximum volume.